Welcome. This is a time series analysis course. My name is Nicoleta Serban. I'm Associate Professor in the Stewart School of Industrial and System Engineering. In this lecture is on multivariate time series analysis, and for this lesson, I will introduce a concept that is very important in multivariate time series analysis, particularly grandeur causality, and I'll also introduce prediction for the VAR model. The structure of the VAR model provides information about the a series of time series and along with forecasting ability for other time series. The following intuitive notion of a variable's forecasting or a time series forecasting ability is due to Granger, who introduced the concept in 1969. If a time series Y1 is found to be helpful for predicting another time series Y2, then Y1 is said to Granger cause Y2. Otherwise, it is said to fail to Granger cause Y2. Formally, we say that Y1 is said to fail to Granger cause Y2 if the mean square error of the model without lagged observations of the time series Y1 is the same as the mean square error of the model with lagged observations of the time series Y1. Clearly, the notion of Granger causality does not imply true causality. It only implies forecasting ability. In a bivariate VAR model with order P for two time series Y1 and Y2, we have that Y2 fails to Granger cause Y1 if all of the P VAR coefficient matrices pi 1 to pi p are lower triangular. As shown on the slide, the coefficient matrices corresponding to pi 1, the coefficients corresponding to pi 1 to location in the matrices are 0. If Y2 fails to Granger cause Y1 and Y1 fails to Granger cause Y2, then the VAR coefficient matrices pi 1 to pi p are diagonal. This means that there is no temporal lag relationship between the two time series. More generally, for an n-variate multivariate time series, we identify Granger causality in the same way. For example, if we have a trivariate multivariate time series, we need to evaluate Granger causality among all pairs among the three time series. If we consider Granger causality on Y1, we need to consider with respect to both Y2 and Y3. We say that Y2 fails to Granger cause Y1 if all the coefficients on lagged values of Y2 are 0 in the equation for Y1 for the first time series, and that Y3 does not Granger cause Y1 if all of the coefficients on lagged values of the third time series Y3 are also 0 in the equation for the first time series Y1. It is possible that only one of the two time series Y1 or Y2 to Granger cause Y3, both, or none. How to evaluate Granger causality? We can use hypothesis testing procedure, where the null hypothesis is that the coefficients corresponding to the Granger causality are 0. For example, if we are interested to identify whether Y2 Granger cause Y1, the null hypothesis is that the coefficients on lagged values of Y2 are 0 in the equation for the time series Y1. More generally, for a pair of time series Yk and Yl among the n time series, we test the null hypothesis that all the coefficients on lagged values of Yk are 0 in the equation for Yl. Rejecting the null hypothesis means that Yk does Granger cause Yl. Last, I will only briefly discuss forecasting of time series in a VAR model. Since the VAR models m time series simultaneously, we will need to forecast all n time series or only those of interest. Since VAR is a multivariate AR model, we can use the chain rule of forecasting. The best linear predictor in terms of minimum mean square error MSE of YT plus 1, or one step ahead forecast based on past data at time t, is obtained from the linear equation of the model by plugging in the lagged values of the time series as provided on the slide. Forecasts for longer horizons H-step forecasts may be obtained using the chain rule of forecasting by plugging in predicted lag values of the time series. In summary, in this lesson, I introduced the concept of grandeur causality, which is of great relevance in multivariate time series. I also briefly introduced the method used to forecast VAR model. Thank you.